Hey there, guys. Thanks for checking out this video. So this is going to be a video on embeddings. We're going to be talking about the new OpenAI embeddings and how to use them within a RAG system. And just to let you know, there is an article version of this video where I explain things in more detail and we go through 8 steps on how to create a vector database and actually put some records within the database and conduct a vector search using a user query. And also we can get access to the GitHub notebook. I'll put all of this in the description, the links in the description below. And also the data set we'll be using will be available as well. So very quickly, what is an embedding? An embedding is a mathematical representation of data within a high dimensional space. And this high dimensional space is referred to as a vector space. And within a vector space, we have this embeddings located in different positions. And this spatial distance, this distance between two embeddings essentially reflects how similar they are in semantics or context. So what can you actually embed, right? So let me just zoom this out a little bit. You can embed pretty much any form of data object. So audio, images, and text can get you could create an embedding vector of any of these data objects. And then we take this representation and plot it within a vector space. The distance of one point to another is mapping the semantic relationship of one point to another. So if you had animals, essentially you have them within the same vector space. Or if you had maybe data object of a certain category, they'll be clustered together. That is the idea of a vector space and embedding within a vector space. But here we're going to be using the new OpenAI embeddings to actually work with to create some embeddings of some data set we have, which is a movie data set, where the new OpenAI embeddings are very good. They offer flexibility. So you can actually embed with different dimensions. So we're looking at 256, 512, 1536 with the small version. And with the large version, you go up to about 3072 in terms of dimension. But what does a dimension really mean, right? So dimension essentially is the amount of context the model is capturing and representing in numerical form. And the reason why you might want to use a smaller dimension than a bigger one, it could come down to storage and also latency, and when you're trying to retrieve this vector. But storage is definitely a very good consideration. In a future video, I might do a comparison of different dimensions and seeing how the recall and retrieval comparison is. In this video, we're going to be looking at the implementation code, which is going to be presented in the notebook, but I have a GitHub repository and I'm going to put the link in the description below, which has all the code that I'm going to be presenting today. There is also a written version of this video that we're going to be going through, which takes you through step by step what I'm going to be presenting here. And lastly is the data set we're going to be using. So this data set, you can access it through Hugging Face and just import it into whatever library or environment you're implementing from. And this is a movie data set, contains about 1,500 movies or so. And the embeddings, it actually comes with some embeddings within it. But we're going to remove this. Each embedding was made with the ADA 002 embedding model from OpenAI, but we're going to be using the new ones today. And these embeddings are generated from the plot of the movie itself. So let's get into the code. So first thing we're going to do is just import the libraries we're going to be using. We're going to be using the Hugging Face dataset library, pandas for some converting imported data sets into data frames, and OpenAI for obvious reasons, and PyMongo, which gives us some abstracted methods to access MongoDB, which is going to be the vector database we're going to be using today to store both the records of the movie and the embedding field as well. Step one, we're just going to be importing pandas in the dataset library and loading our dataset from the Hugging Face embedded movies directory right here. And we're going to access our data set and just view it, just for visualization purposes, and see what it looks like. And we can see we have different columns, but more importantly, we have the plot column, which created the plot embedding we can see here. And this embedding, the dimension of this is 1536. But remember, we're going to be removing this and replacing it with an embedding from the new OpenAI model. First, just some cleanup over here. We're just going to see which part of our data set have missing plots, just to make sure we have clean data. And we can just see the stats on this, and we can notice that 27 data entries have no value in the plot column. So we're going to get rid of those. And that way we can make sure everything that we're going to be putting into our database has a plot that we can embed from. So here we go. So we're just going to drop any columns, any rows, any rows that doesn't have an entry in the plot column. And then we can just check the numbers that we have again. So right here, we can see that we've got no plots. We've got no data entries without plots, which is very good. So we've got some good data to work with, and we could just visualize it again for confirmation. Additionally, actually, we've removed the plot embedding column from the entire data set. So we don't need that. We're going to be replacing it with an optimized version. Next, here's the good part where we're going to be creating our embeddings using the OpenAI client. And then one thing to note is you do need your OpenAI key. So do you get that from the OpenAI website? I've kept a link here so you can just access it and get your API key. And I'm using the Google Colab environment, the secrets environment, to store the key. And I'm just using the user data module to access that. And here we have a text definition of the model we're going to be using. And this function essentially just calls the OpenAI embedding, the create embedding method, and then call that method for every single plot column, for every single plot entry we have in our data set. And that will essentially give us the embedding we need. And with the new embeddings, you can actually add another argument here, which is just the number of dimension, I believe. If I can spell that properly, and you can just specify any of the dimensions you're going to be using. I'm still going to be using 1536, but you can change. Default is 1536, but you can just change it to 256. You want to use any other dimensions. Anyway, I'm sure I'm spelling dimensions wrong, but we can do that for a future video. Essentially, when we do that, we can just view again that we have the right data. Just looking at the head of the row, which is the top 5. And here we have the plot embedding optimized with all the embedding for each data row. Next, we're actually going to set up our database. So setting up your MongoDB database is very straightforward. You can just click on this link over here just to get access to it. And once you do have access to it, you would have to grab the link, the cluster URI for your database, which will allow you to connect it to your database using PyMongo. And I can actually quickly show you how you can go through this process. Once you get into MongoDB, you're going to have a view like this of your dashboard. So if you just click on database, and if you click on create, and with MongoDB, you can get a free database, a free cluster. And you just click on free, choose whichever provider you need. Generally, I choose AWS, and just basically choose a region. You can just choose whichever data centers are located next to you. And yeah, and that's all you need to do. For those of you that like to label your deployments, you can actually add a key and a value. So you can put something such as environment, and this would be development. And then you just click create your cluster and give it a few minutes, and your new cluster will be created where you could go in and create your database. Essentially, you're going to need to connect to your cluster, and you need to grab the URI for your cluster. But if we could just go back to the code, once you have your URI, you'll be able to connect to your MongoDB cluster using PyMongo. So here we're gonna get an instance of our Mongo client that basically represents a connection to our cluster, which can allow us to access our database and collections. Right here, we're just gonna get the URI from the Google Colab environment secrets, and we're just gonna create an instance of this and then get the database. The database, we're gonna create something called movies, and then the collection within the database that holds all the records is gonna be called a movie collection. My naming is very basic. So right here, once we've done our connection, we're printing out the statement connection successful, just to indicate that it's connected. I also have done this several times. So I have a little line here just to delete any entries, just to make sure I have a fresh collection. If you haven't created your database and collection yet, don't worry. Once you go through this step, ingesting data into MongoDB will actually create a database and a collection automatically. So one thing we're going to do is we're going to convert our data frame into a dictionary, which allows us to insert all of this data set right into the movie collections right here. So this has become a PyMongo object. So we have the ability to conduct different methods that allows us to interact with our cluster and database and collections. So we're going to use the insert many command, which allows us to insert in batch. And once that is done, you can always go to your database to verify that this is done. But I'll show you what it would look like. The next step is actually very crucial. Step 6 is where you have to create your vector search index. And this is essentially an index essentially allows you to query very efficiently records within your database. So let me quickly show you what it's going to look like. So you go into your collections and we have the movie collection, right? We're going to our movies database and we have the movie collection here, and we have about 1,473 documents. And each of these have this plot embedding optimized document. So that's successful. We've just added the documents with the embedding into our MongoDB collection called movie collections. Next, what you're going to have to do is create your vector search index. And I could walk you through the steps. I've created a few, but here you just create a search index. You click create a search index over there. Then you just want to use the JSON editor. You want to create that Atlas Vector Search Index. And you click next. And here you're just going to have to select the database, then select collection you want to create the index for. And you just call this vector index test. And then what you can actually do next is we're going to put the definition of our index over here. So here is what it's going to look like. We're going to change the number of dimensions is 1,536. If you're using any different dimensions, you can put 256. Just if you're using a different dimension of the small or large model. So our embedding field is not called embedding, it's called plot embedding optimized. And then I think it doesn't recognize this curly brace, it's quotes. And there we go. So this is the cosine is the distance measure it's going to use. Other options are Euclidean and dot product. And yeah, just click next and your vector search index is going to be created. And if you go back to the code, once you've gone through step 6 and created a vector search index, one thing we're going to do is create a function that performs the actual vector search. So we're going to call the function vector search, and it's going to take a user query, which is going to be a string, and we're going to have the collection we're referencing passed into this function as well. So we have the query embedding. We're going to use the embedding method that we created earlier to convert the user query into the numerical representation that we can use to pass into our vector search query. Right now, we also have just capturing if there is no query embedding, we just return an invalid statement. So we're going to create a search pipeline, and it's going to be a vector search pipeline. And here we're going to say with MongoDB, you can easily have a syntax that resembles JSON to actually access your data, your data on your records, and perform operation on your records. So what we're doing is we're going to use the vector search command. I'm also going to let this query use the specific vector index that we've created. And then we're going to pass in the actual embeddings as well. This is what it's going to use to conduct the query. The path is also going to be utilized. The path where the other existing embeddings are will be specified here. We wanted to consider 150 matches, but only return 5. So there's a similarity score there's a score associated with every record when it does a vector search. I really want to return the top 5 matches essentially. And here we're running a projection of the data we want back. We don't need the ID back from the query. We do need a plot, we need a title, and we also need the genre. And we're also going to get the scores as well. To save on some space as well, we might also you can ignore the plot embedding optimized as well, as we might not need that. So you could just remove that from the projection, so it would not be returned from the query. This could save on space later on if you're doing anything further down your RAG pipeline, but you're not going to be doing anything with embedding data, so you can just remove it from the results returned from the query. So here we're going to get the results, and we're just going to run the query and just run it in our collection using an aggregate function. And that will essentially return a list of documents that actually match the user query in terms of that semantically match the user query. And that's what that function is going to do. And that's the return will be a list of the top 5 results that match the user query semantically. Now we're going to create another function to handle the user query. I'm not using any libraries such as LangChain or Llama Index, so we're just going to do this with a bit of code. So we have a variable called getKnowledge, which is essentially going to do a vector search based on a query and the collection. And this is going to give us our list essentially from our knowledge source. And once we get the additional context, we're going to essentially extract what we need from it. I just need the title and I need the plot. I'm going to give this additional information to add it to the query that we send to OpenAI, to the LLM. And we're just going to add it as a search result essentially. So we're going to create the definition for the system, a movie recommendation system, and we're going to tell it to answer the query using the knowledge we've provided it with. And that's essentially what a RAG system does. We're augmenting the query with some truth, essentially, which is a data source. And this allows us to get more relevant and accurate results. So we're just going to return, 2 things actually. We're going to return the response from OpenAI, and we're also going to return the search results just to view what we've used as the information, additional context for our query. Next, we're just going to create a very simple query. What is the best romantic movie to watch? Don't know why I choose romantic movies, but what is the best romantic movie to watch? And we're asking that to OpenAI model, and that's going to give us a response. And we're also going to extract the source information that we've used to essentially get the answer from. And here we go. So the response is China Girl, never watched, but it tells you the plot as well, which was added in for additional information. But we can also see the other options it could have chosen from based on what we extracted with this query. So what happened was this query was converted into an embedding, which is a vector that contains numbers. And this was essentially used within a vector search with our collection within a MongoDB database. And it matched the top 5 movies within our data set that were romantic with these movies here. But the one that it selected was China Girl. So in future videos, I could show you additional stuff such as the score, the similarity score returned from MongoDB when it's conducted a vector search. And we could look at maybe trying out other queries or even benchmarking the retrieval. So that's it for this video. So just remember, there's an article version of this linked in the description. There's also the notebook here, which you can just access and play about as you see fit. And you can also just get the data set. For those of you that don't want to spend money doing your embeddings, you can just use this data set and experiment. And we experiment with vector search. So thank you guys, and I'll see you in the next video.